Hello, I'm Professor Robbie Pott from the Department of Chemical Engineering. Welcome prospective students to this discussion of chemical engineering, the offering that we have here at Stellenbosch University, our department, and the kind of things that you can do with chemical engineering once you've graduated. In terms of what we offer, the department has some fantastic world-class facilities. We have a wonderful pilot-scale laboratory, which you can see here. We've got some good experimental laboratories, and we have space for our undergraduates to learn. The kind of people who are going to be teaching you include the lecturers who you can see here. So we have professors, lecturers, senior lecturers, and so forth from various backgrounds, some of which who have excellent industry experience. And these are the people who will be teaching you the fundamentals of chemical engineering and how to be a good engineer once you go out into the world. Some notable achievements and collaborations that our lecturers and our professors have is we have two distinguished professors, so those are very senior professors, Professor Johan Gergens and Professor Stephen Bradshaw, and they have been ranked in the top 2% of researchers in their disciplines globally. So we have some really excellent researchers working in our department. We have many of our lecturers are senior staff on editorial boards, which means that the kind of work that we do in our department is internationally recognized, is internationally accredited, and so you know that the work that we're going to be doing as part of your undergraduate and postgraduate degrees is some of the best in the world. Most of our staff members have PhD degrees, so your lecturers are very well educated in the spaces, and we are very proud of this, that for the last 6 consecutive years, staff members in our department have received Stellenbosch University either institutional or faculty teaching excellence awards. So the department is not only focused on fantastic researchers and doing good research, but also on providing an excellent undergraduate offering. Our work also follows international collaborations, so we have people who are doing some fantastic stuff across the globe, including Professor Neil Goosen, who has until recently been the director of the Arua Center of Excellence in Energy, which is the African Research Universities Alliance, an international consortium of universities. We are also very lucky to recently have had Professor Prathika Naidu awarded the NRF Saatchi Chair in Green Hydrogen, and Professor Johan Gergens, who we spoke about earlier, he has the Saatchi Chair in sugarcane biorefineries. And then Dr. Margaret Tardy is also now running our interdisciplinary RM research chair in geometallurgy. All of this is to say that the work that we do in the department is very well recognized internationally, and you will be taught by some of the top minds in the field. As part of this, we do research in a variety of spaces, including bioresource engineering, which is my area of expertise, using organisms and biological materials to make valuable chemicals and to do environmental engineering. We do extractive metallurgy, which ties in very nicely with the very large mining and resource engineering in South Africa. We have a strong group in separation technology, which ties in nicely with petrochemical industries such as Sasol, as well as other industries like purifying products from biomaterials. We've got waste valorization to take what has been discarded and convert it back into valuable materials. Water technology, very important in South Africa, a water scarce country, where we're doing things like developing processes so that we have access to water in rural areas. And then machine learning is a technique, basically using artificial intelligence and machine learning to do all of these things in a better, more efficient fashion. Some of our alumni have gone on to do some really exciting things internationally, and there's too many to talk about, but we've got a few that are fantastic. We got our alumni going into, for instance, biomedical engineering. One of our alumni recently won the Africa Prize for engineering. We've got some of our alumni who are now doing advanced degrees overseas, such as Apiwe and Natalie. So yes, our alumni are very well recognized internationally. They go on to do degrees elsewhere and have great success Our undergraduate degree is a strong one, which then allows you to go on to other places. So then what might be on your mind is what exactly is chemical engineering? So it's not quite chemistry. We don't just do sort of reactions in small vials. It's not just physics or mathematics. What we actually do is draw on these fundamental fields to design, develop, and optimize processes to take raw materials and convert them into valuable products. So basically we're doing production, making valuable materials, transformation, converting one thing into another thing, and then utilization, then making it into valuable products. So things like energy to make petrochemical products, plastics, petroleum, diesel, and so forth. Chemicals, fine chemicals, such as, in this case, we're growing algae to make, for instance, polyunsaturated fatty acids for use in food, or materials, so plastics or other things. So the degree that we have is a 4-year degree. You'll be taught in this kind of classroom, in a lecture style. You'll also be doing quite a lot of laboratory work to be hands-on with the content. And it focuses in the first year on some strong fundamentals, things like engineering drawings so that you can visualize in 3D space, fundamental chemistry, some really strong focus on fundamental mathematics. So that's the first year. Then we go on to more application of these fundamentals in actual industries, things like wastewater treatment plants. What does the chemistry of such a thing look like? Combustion, what do the thermodynamics of such a space look like? Into the third year, we then go into more advanced topics, drawing on the fundamentals that we did in the first and second year to look at, okay, what is a reactor? How does that work? How do we do fundamental chemistry inside this thing, as well as transport phenomena? How does the energy go in and out? How does the heat work? And in this example, we have some biological processing. This is an enzyme producing a product. And then in our final year, we then reach our capstone modules, where we integrate all the knowledge from the previous 4 years to design integrated complex processes, to do some fundamental modeling of what's happening in those processes so that we are always on top of the product that's going in and the raw material that's going in the product that comes out. Visualized, this is what your 4 years look like. We've got some fundamental mathematical sciences in this kind of brown color, natural sciences in yellow, engineering sciences in gray, and then additional things, complementary studies in pink. And you can see that there's a focus in the first year on some fundamental mathematics and chemistry. Second year also then starts to bring in some fundamental engineering sciences like fluid mechanics and thermodynamics. And then we get into some hardcore engineering in the third and the fourth year. And underpinned throughout, we are trying to make sure that you are a well-balanced engineer, able to integrate well into the world of work. So we have some images of what's happening here at the bottom: fundamental mathematics and chemistry, reactor design, modeling, and then finally what we finally get to is a fully integrated design at the end. And we've got 2 capstone modules that allow you to tie in all what you've learned over the previous 3 years in our final year research project, where you'll be given an open-ended research project like grow an organism that produces volatile fatty acids that then we can use in the green plastics industry, or something like that. And then the design project, which then we ask you to design a plant such as this water treatment facility over here. So the idea behind doing chemical engineering is that we want you to go out into the world and make a difference. Chemical engineering is fundamentally an applied science. So we want you to then take this knowledge that you gained over the last 4 years and apply it in industries of various types. And we are lucky in that chemical engineering, our graduates go into a very wide variety of fields after graduation, not just engineering, but consulting, finance, R&D, various places. So let's cover some of those now. So one of the fundamental things that we do is take raw materials such as grapes or ore or sheep products, for instance, water, and convert those raw materials into valuable products. We design and build plants. So here we have a reverse osmosis plant. So when South Africa was in or particularly the Western Cape was in a water crunch a few years ago, chemical engineers were the ones who designed those reverse osmosis plants that allows us to take in seawater, separate out the salts, get clean drinking water out the end, so that we continue to have access to water. We operate and manage chemical engineering plants and people, so from small scale to larger. So here's some nice open ponds. We manage and operate these kind of plants, and we'll have people working under us, such as civil and mechanical industrial engineers, who then help us realize the development of these larger plants. We do some consulting as well. Many of our graduates will go on to work with the large consulting houses to help businesses do what they do better. We are fundamentally concerned with processes, and whether the process concerns raw materials or money, the inflows and outflows are things that we can give input on. And then the final one, we do research and development to develop new processes and materials, such as using biological materials or separation processes to develop new things. So the kind of tasks and responsibilities that you will have as a chemical engineer include developing processes and optimizing them, safety, environmental compliance, troubleshooting and problem solving once you're on the plant, R&D and plant construction, economics, project management, collaboration and communication. So you can see that we do many things. We provide a fundamental understanding of engineering and science so that you can have your finger in a variety of pies. So the kind of places that chemical engineers work and where we work with other engineers such as mechanical, electrical and so forth, researchers and scientists, and so forth. So yeah, we work in chemical manufacturing, oil and gas, energy, pharmaceutical and biotech, food and beverage. So the cornflakes that you had in the morning, a chemical engineer was involved in the production and development of that, and so we go. In terms of how to get into our program, it is a challenging program, and so we have quite high requirements for entry. For those coming from a NSC or IB background, we will use your final grade 11 marks to do the initial entrance, and we need an average of 70% with maths at 75 and physical science at 65, with some specific language requirements. We do exclude life orientation from those calculations. The main selection mechanism is your selection score. To calculate that, we take maths and science plus 6 times the average, excluding LO. All right. For those who are coming from a different school system, we then use the 5 subjects we have there. And the requirement that we have is a 620 for this number, which means there's quite a high entrance requirement because the course is challenging. But if you do well in particularly maths and science, then engineering may be a good route for you. If you do achieve 620 on your grade 11 marks, we will then send you a conditional offer. And if you maintain those marks or improve them, then you will receive a final offer. In fact, even if you get the minimum entrance requirements, you will then you'll be sent a final offer. If you have any questions, we have a person who is specifically tasked with assisting potential new undergraduates called Jeannie, and she can help you. I'd like to point out that there are many bursaries in chemical engineering because we work so closely with industry. So from the department side, if you do very well, we have our first year bursary. So if you get above 88% for matric, then you will receive some money from the department. There's also a Stellenbosch-based merit award, which and these two you don't have to apply for specifically, but if you do well, that's an incentive for you to come and join us. And then there's many industry bursaries, either linked directly with companies or funded by general industries, so that you can come and join us. So good students will usually be able to get a bursary either in the first year or very soon thereafter. It's worth investigating. So that's a little bit of a background of chemical engineering specifically. If you would like some more information, you're welcome to email Ginny or come and have a look at our website. There's lots more detail on our website about the specific programs that we have. Feel free to follow us on Instagram or LinkedIn or Facebook, and here are our handles for that. Thank you for your time and attention. I look forward to seeing you join us again at Stellenbosch. So that's a little bit about the background of chemical engineering itself. Please feel free to contact us if you've got specific questions, and we look forward to welcoming you in the future.